Hi everyone. In this video, we're going to complete the square to find the vertex. Remember that the reason that we would even want to complete the square in the first place is because it transforms the parabola into vertex form and makes it really easy for us to see what the vertex is and what the transformations are. This first example is going to be complicated but not terrible. Complicated because it has all of the steps, but you'll see why it's not terrible when you notice some later ones that we're going to do. We're going to take the standard form equation f of x equals negative 5x squared minus 30x minus 43, and we're going to complete the square on it to turn it into its vertex form. First, we're going to rewrite this as y equals. You don't have to do this, but I think you'll find this easier to work with than the function notation. Next, we're going to draw a blank on both sides of the equation. Notice on the right side I put the blank after the quadratic term, the x squared, and the linear term, the x. Then I'm going to make a group out of the quadratic term, the linear term, and the blank. Next I'm going to factor the a coefficient, so that's the negative 5 in front of the quadratic term, out of the parentheses. When I factor the negative 5 out of the parentheses, I have x squared plus 6x in the blank left inside, and I can check this by redistributing the negative 5 to check that I could still get what I had originally. So negative 5 times x squared is negative 5x squared, and negative 5 times positive 6x is negative 30x. So that shows that this is still valid. Now I'll actually fill in the blank and complete the square. So 1/2 times 6 gives me 3, and then 3 squared gives me 9. However, I didn't just add 9. Because of the negative 5 in front of the parentheses, I actually added negative 5 times positive 9, or negative 45. So I also then need to subtract 45 on the left-hand side of the equation. After that, I'm going to factor the parentheses into a binomial squared. Recall from the previous step that half of 6 made positive 3, and that's the number that goes into the binomial squared. I can verify this by distributing back out x plus 3 quantity squared to show that it in fact does give me x squared plus 6x plus 9. I can also notice that the number has to be 3 since both sides of the square we would be thinking about here would have a length of 3, and 3 times 3 is 9, and 3 plus 3 is 6. Lastly, we finish isolating the y variable by adding 45 to both sides, and I can only combine the plus 45 with the constant on the other side. So finally, I end up with the equation y equals negative 5 quantity x plus 3 squared plus 2. This is great because now I can really easily see that this parabola had a vertical stretch of 5, reflection over the x-axis, and was translated 3 units to the left and 2 units up. I wasn't able to see this as easily by looking at the standard form of the function. So this is the basic procedure for completing the square. This has all the steps. Some might be a little more complicated because of fractions, and some might also be easier if we get to skip some steps. We'll look at a couple of those in a couple of other examples.